Good evening, everybody. Could you please confirm if I'm audible?
Yes, Szen, yes, you're audible.
All right, thank you. Good evening once again. A very warm welcome to you, all of you. Thank you all for registering and attending this workshop on containers and OpenShift, which is being organized by IPSR Solutions Limited India in collaboration with Valin UK, US, and Canada. In this workshop, you will get to know how OpenShift revolutionizes the process of bringing AI-enabled apps to production faster, and why is OpenShift a game changer in this AI era? Now, my name is Szen Jacob George. I'm working as Global Relations Manager with IPSR Solutions Limited, and I will be the event moderator for this event. Now, please note, all of you, that all the registered participants will receive access to the LMS, that's the Learning Management System, through which you can download a certificate for this program. And also, all the participants will receive the LMS login credentials in the registered email by tomorrow. Your certificate will be ready for download in the LMS by Saturday. You can also alternatively attend the session through YouTube Live streaming, which will be available through this link. I'll put that in the chat now. Okay, so if you're having any difficulties with WebEx, you can also join with YouTube Live through this link that I've put in the chat now. Now, a few introductions about IPSR. IPSR is led by a team of academicians and entrepreneurs. IPSR is a public limited IT company with 24 plus years of expertise in software product development, training services, placement services, and web-based services. During the last 2 decades, IPSR has worked with over 500 academic organizations, including government universities, autonomous colleges, technical and non-technical institutions. IPSR's training division conducts faculty development trainings, seminars, workshops, add-on courses, corporate trainings, job-oriented trainings, etc. in the education, IT, and IDES domain. IPSR were the training partner for the Technical Education Quality Improvement Program, TECH-IP, a World Bank assisted project executed in government engineering colleges by the Indian Ministry of HRD. IPSR is also the world's leading Red Hat training and certification partner with 37 national and international awards, and has produced the highest number of Red Hat professionals in the world. So far, IPSR has trained candidates from 60 plus countries. IPSR IT Services Division is a pioneer in development of academic solution products, incorporating cutting-edge technologies like artificial intelligence, data analytics, and machine learning. Currently, IPSR offers specialized services and solutions for the education sector, ranging from simple websites to complex software applications that help to manage academic and operational activities like question paper generation, campus automation, accreditation process, NAC, NBA, etc., and OBE, outcome-based education. IPSR's placement division is having 1,600 plus placement type companies and are conducting recruitment on all days. Now, coming to the introduction about Valin. Valin Technologies Limited is an IT company having branches in the UK, USA, and Canada. Valin brings the next generation innovation and value to manage IT services delivered seamlessly through the prompt end-to-end solutions and global service delivery channel. Valin also provides internships for students in the UK, USA, and Canada. Now, before we move on to the introduction of the resource person, if you all could possibly turn on your videos for 30 seconds, we would like to take a screenshot for our documentation purpose. All right, let's proceed. Today's session on containers and OpenShift will be taken by Mr. Szen John Providence, who is an M.Sc in and RHCA, RHCI, and he works as a manager technical services for IPSR Solutions Limited. Now, Mr. Szen John Providence is a Red Hat certified architect and also a Red Hat certified instructor with 16 plus years in the IT industry in India and UK. He has completed his M.Sc in computer networking from London Metropolitan University. His expertise is in computer, cloud computing, Ansible, etc., and makes him a popular corporate trainer and has trained candidates from Americas, Europe, Middle East, Africa, and Asia Pacific. He has got global IT certifications in Red Hat certifications of Red Hat Certified Specialist in OpenShift Administration, Red Hat Certified Specialist in Containers and Kubernetes, Red Hat Certified Engineer, and Red Hat Certified System Administrator. Now, over to you, Szen.
Okay. Thank you, Szen. Okay, let me share my screen. Okay, I started sharing my screen. Can someone confirm me, please?
Yes.
Yes? Okay, thank you.
Yes, screen is visible.
Okay, thank you. Okay, good evening, everyone. Once again, welcome to this workshop on containers and OpenShift. Yeah, I'm just making it full screen. Is it visible to everyone? I've just made it as a full screen.
Visible, Szen. Proceed.
Okay, yeah, thank you. Okay, so in this today's workshop, we are going to discuss what is containerization, what is the process of containerization, and by doing the containerization, how we can create containers, then container orchestration like Kubernetes, and finally, one of the platform as a service from Red Hat, that is OpenShift. Okay, before we start, let me know, please, how many of you heard about these keywords like containers, Docker, Kubernetes, or OpenShift? Any of these keywords? Could you please type in the chat box, yes or no? If any of these keywords you already familiar, or like containers, containerization, container orchestration, Kubernetes, Docker, etc. Yeah, those who are not heard about this, no worries, because we start this session from the very basics, like yeah. So no issues with that. Yeah, just I want to get some idea about the audience. Yeah. Okay, fine. Yeah, thank you. Okay, so we'll be having introduction to containerization, container orchestration on OpenShift, and also demonstration of how to create containers using Docker, then how we can create applications from the source code and create images, then deploy in a platform as a service named OpenShift here. So before we go to the containerization, let's look into the history of deployment mechanisms. So in earlier days, we used to deploy our applications in a physical server, then operating system, then on top of that, our applications like application 1, 2, 3, like that way. But sometimes we may get issues like application conflicts or dependency issues with operating system. So basically, we need to isolate that application if any one of the application is making any issues with running. So we need to isolate the application. So in virtualization, we create virtual machines, right? So if you look at this picture, so we create virtual machines, and inside the virtual machines, we run the applications in an isolated environment. So here, the application 3 is isolated from application 1 and 2. And application 1 and 2 is isolated from application 3. Yep, we have the solution here to isolate the application so that there is no issues like conflicts or dependency issues. But think about the resource utilization. So the 3 applications were running in a single operating system, a single physical server. When we virtualize the applications with the virtual operating system and virtual machines, you can see that additional resource utilization by the virtual machines, the additional resources utilized by the operating system, the kernel. So just to isolate the applications, we had to sacrifice the utilization of additional resources like CPU, memory, storage, etc., with additional virtual machines. But we are actually looking for a solution, like we need an isolated environment to avoid any kind of issues like application conflict or dependency issues. Yes, we had a solution with the virtualization, but not in a cost-effective way. But in containerization or in a containerized environment, we can run the applications without any dependencies. I mean, all these applications are running in an isolated environment with help of containerization technology, which is managed by any one of the container engines like Docker, Podman, Cryo, etc. So the container engine manages the life cycle of container. So what is container? Container is nothing but an isolated process in an operating system. So in user point of view, it's an application, but it's completely isolated from other applications or an operating system on which the application runs. So it can be, the containerization can be implemented in virtualization also. Like the same thing I'm going to demonstrate in AWS account. So in AWS, I create a cloud instance. In that, I install the Docker runtime, and using the Docker runtime, the container runtime, we download the images, we run the containers in AWS account. So in virtualization, VM isolate the hardware. With help of virtualization technology, we create multiple virtual machines like different set of CPUs, memory, storage, etc. Right? So it isolates the hardware. But in containerization, container isolates the process in a single operating system. So this is one of the definition I can say, like for the container, that is, it's a lightweight. If you compare a container with the virtual machine, it is very lightweight, standalone and executable software package, which contains everything needed to run a piece of software, including the code, runtime, system tools, libraries, and settings. So that is containers. And the process of creating containers, we call it as containerization. Yeah, so let's look into a demonstration of container and how we can create containers using container runtime, called a Docker. So if you look into this picture, this is our client system. Okay, and this is the host machine in which I'm going to run the container. And this is the registry. Because for creating containers, we need image. Just like for installing operating system, we need ISO image, right? For creating virtual machines, we need virtual machine image. Same way, for creating containers, we need image. Either you can create a new image using Docker file, that is something advanced in containerization. But just for a beginners, I recommend download images from a container registry. That's what I'm going to demonstrate today. So we have container registries like Docker Hub, from where we can download the image to our Docker host, our containerization server. Using that image, we can create the container and we can make use of that container. So that container can be in a web server or a database or any other application servers. So using Docker command, we can pull the image from registry. Using Docker run command, we can create and run containers. Using Docker build command, we can create a customized image from a Docker file. Docker file is nothing but a script of instructions which will help you to create a customized container image. And using that container image, you can deploy your container in a Docker host or any kind of containerization host. So let's move into the demonstration of creating containers. So I have the AWS account here. So in AWS, I'm going to launch an instance. So why we need an instance here? So we need the Docker host. The registry is already there because we have the public registries available, and Docker client, that is my laptop in this scenario. But we need a host machine in which we can deploy our container workloads. So for that Docker host machine, I'm creating this Docker host. I'm just giving a name. I'm going with the default free image from Amazon, that is Amazon Linux. Going with the free tier resources, that is 1 CPU and 1 GB is enough. And a key pair just for accessing my Linux host machine. Yeah, since I'm going to create a web server, I'm allowing traffic HTTP and HTTPS. Yeah, that's it. Just launch the instance. So don't worry about launching instance in AWS. Don't worry. Later on, I will show you some other free resources in which you can create the containers. But just for those who have access to the AWS, yeah, they can spin up an instance in AWS and they can work on it. Yeah, anyway, I'm going to give you different sources of practicing our labs, either in AWS or in later on when we discuss the OpenShift. Yeah, so we'll give another free labs, not in AWS. I can provide you another free labs in which you can run our workloads. This is just to demonstrate how the containers runs in AWS host machine. Okay, my instance is getting ready. Yeah, it's running. So just think like this is a platform, just an OS installed machine. Whether it is an AWS instance or in your local machine or a VMware or VirtualBox machine, it doesn't matter. Just think that this is just a machine installed with an operating system. I'm just using an AWS. That's it. Okay, so I'm connecting to that instance using SSH. Basically, I need that SSH terminal of that instance that I can run Docker command for my virtual application. So establishing. So this is a Linux terminal. I'm just switching to those who are not familiar with Linux. Don't worry. I'm just switching to administration privileged profile, that is root. Basically, it's administrator profile. So there I'm going to install the package yum install. This is the command to install a package in Linux, yum install Docker, because I'm going to use Docker as the container runtime. So please note Docker is the container runtime here. So there are different runtimes like Docker, Podman, Cryo, etc. But here, and the most popular container runtime is Docker. That's why I choose Docker to demonstrate containerization and I mean creation of containers in my demo. So Docker is installed, then make sure that that service is started. So I use systemctl command. Systemctl start Docker. I'm doing this process. I'm going to start the Docker daemon, or it's called a background process like Docker D. So for starting and running that service, we need the software package, right? We need the software package. That's why I installed that package here. So I installed using yum command here. Then start Docker. Then what we need? We need image. We can get image from registry, one of the registry called Docker Hub. It's a public repository for images. So graphically also you can search like Docker Hub. It's a repository of container images. So it depends on your requirements. You can search for the images and download. So for basic understanding, I'm going to deploy a Apache web server. Okay, it's just a web server. And Apache, I use Apache for serving my web page. So for getting that Apache web page, I use the image named HTTPD. So this is the command for creating a container using an image. So the command is docker run for create and run a container, and run this container in a background. So you know one thing, a container is actually a process, an isolated process in an operating system. So the process can be a foreground or background. So I want to run this process, this container in background. That's by -d detached mode. Then port forwarding. Don't worry about this networking at all. Once we start with OpenShift, all this manual work and all will solve by container orchestration. So initially, I just want to demonstrate how difficult it is to manage the containers. I mean, thousands of containers, not a single container. If there are thousands of containers, how difficult it is to manage without a container orchestration. Just for that reason, I'm doing everything manually, because we all know that we are in the era of automation and AI. So we can automate, and with the help of AI we can deploy the containers smartly with the help of automation and container orchestration engines. That is what we are going to see with the Kubernetes and OpenShift. But before that, or without the orchestration or automation, how difficult is to manage our containerized environment. Demonstrating first, so later on, I will use the Kubernetes and OpenShift. Then by that, you will see that how easily we can deploy our applications, or we can scale out and we can automate our applications. Okay, so this is just to understand the difficulty in manual administration. So Docker run -d, then -p is the port number in host, and another 80 is the port number in the container. Then we need the image, right? So the image, I don't know where exactly where exactly the image is, and I don't know what is the name of the image, but I can just mention some keywords like I'm sure that I need a Apache image, HTTPD image. So this Docker will search for HTTPD image in this registry. So it will search for the HTTPD image in the registry and will download and create a container. So that is what we are going to see. So Docker run will create and run a container. Actually, it runs in the background. This is for networking, port forwarding, and this is the image keyword, that is HTTPD. So now I enter. It's okay. It's saying unable to find image locally because we need to keep that image, or we need to make that image available locally, but that is not available locally. It automatically downloads the image from the registry. So now when I type Docker images, I can see that the image is downloaded locally. And also Docker ps command confirms that our container is running. Our container is running, and I can check locally like localhost. This is a command line command to check a website. So it says it works. So this is my public IP of my instance. So if you can paste this IP in your browser tab, you will get this result. It works. So I'm just pasting that IP address in the chat box. Yeah, please check in the web browser. Are you able to see this page? It works. Yes, it works, right? Yeah. Everyone, please check this URL. Shiaz is saying no. Make sure that this is HTTP, not HTTPS, because I didn't configure any security here. This is HTTP because some browsers automatically takes it as HTTPS. So please make sure that it is HTTP, then IP address. If it is not working, maybe issue with this protocol. Make it HTTP, yeah? Okay, so I'm sure that this is working for everyone because this is a public IP which is running in AWS. What I'm trying to demonstrate here, yeah, by now you know how to create a container. But the question is, if this container crashes, if this is the container application in a production, and if it crashes, what will happen? We didn't configure any load balancing, right? We didn't configure any load balancing. We didn't configure any auto scaling. So load balancing is for high availability. High availability in the sense, if one container goes down, there should be another, at least another container to save the web page, right? That is load balancing. So we can run two containers at a time. So if any one goes down, automatically another one will be able to manage the request. Or if both are running, if there is huge traffic, yeah, all these two or three containers can manage the traffic with round robin algorithm, round robin fashion. If that two or three container is not enough to manage the traffic, what we can do, we can configure auto scaling so that the containerization technology. I mean, there should be some technology to automatically scale out. Like if it is 2, if it is minimum 2, it automatically increases to 3, 4, 5, like that way up to some value. So that is somewhat called auto scaling. But here, no load balancing or auto scaling, because if I accidentally delete this container, there is no self healing as well. No self healing, no load balancing, no auto scaling. So I'm going to delete this Docker RM. First, let me get this ID of that container. That is Docker RM. Let me stop. That is enough to show you situation just like if it is crashed. Now the container is stopping. See, the site cannot be reached. Just imagine that container crashed. The container crashed. So no availability of another containers here. So these are the limitations of just containerization. I'm not talking about the limitations of containers. If you just go with the containerization in a production environment, maybe this is okay with the developer environment, because for developers, they just want to develop their application and make sure that whether it is running or not. But for operation team, for in a production environment, this has to be highly available and scalable. So for that, we need something called container orchestration. So we just discussed about containerization. Through containerization, we create containers, which is nothing but isolated processes. But when it comes to production environment, when it comes to an environment where large number of customers or clients connect to your server, it has to be highly available and scalable. So without container orchestration, that means just what we demonstrated. If you want to scale up the services, manual work increases. If it crashes, it crashes in the sense it may be the container crashes or a node crashes, I mean host crashes. Yeah, manually we have to manage it. And complexity for running new stuff in production increases. Human cost of running services increases. Scaling becomes more and more difficult because everything we need to do it manually. And public cloud providers bill more and more expensive because sometimes if there is no auto scaling or load balancing, we may scale up our resources, like instead of 1 CPU or 2 CPU, we may increase the resources so that unnecessarily we may end up with utilizing high amount of CPU and memory. So this is without container orchestration. Just containerization, these are the limitations. But with container orchestrations like OpenShift and Kubernetes, yeah, we'll compare the difference between OpenShift and Kubernetes. So the most popular container orchestration is Kubernetes. So please note, Docker is a containerization engine or container engine for creating containers or for managing the lifecycle of containers. But we need container orchestration for self-healing, automated rollbacks, auto-scaling, load balancing. So container engine will take care of containerization, and container orchestration will take care of this automation of this. So self-healing means what? We expect if there is any crash of node, if there is a crash of container, it automatically creates another copy of the container, which is not happen in my demonstration, right? Because that is just a containerization. So we expect with self-healing, like it automatically creates a new one if there is any downtime or crashes with a container. That is self-healing. Automated rollbacks means if there is any error in updation or a new deployment of an application, it automatically roll back to the previous stage automatically. I'm not talking about manual task. It has to do automatically. So that is automated rollbacks. Then auto scaling means, just like just now I told that auto scaling means depends on the traffic comes to the application. It automatically increases the number of replica. The number of replica means by default, if your application is served by 2 containers, it automatically increases to 3, 4, depends on the threshold. In auto scaling, in demonstration, I'm going to show you that. In auto scaling, you can configure like when the threshold, the CPU threshold reaches 50% or memory threshold reaches 50%, automatically create another container and add to the load balancer so that instead of 2, 3 containers will serve your workload. If that is not enough, 4, 5, 6 up to the maximum limit. So that is auto scaling and load balancing, which is the name itself says, which is actually manages the workload between multiple containers. So this is possible with container orchestration like Kubernetes. So using Kubernetes, you can automate the configuration, provisioning, availability, scaling, security, resource allocation, load balancing, and health monitoring. So this is Kubernetes structure, architecture. On top of operating system, we can run any container runtime. Of course, we need a container runtime for creating and managing the life cycle of containers. So it can be a Docker, Podman, CRI-O, etc. Any container runtime. Then Kubernetes for container orchestration and management. With Kubernetes, there will be etcd, that is for storing the cluster state and configurations, which is actually responsible. For example, when you configure a load balancing or auto scaling, or minimum how many replica, and with minimum how much resource for launching our application, and maximum how much resource that application can use. So these kind of parameters are stored in etcd, the cluster state and configuration, just for example, as I say. So this is a Kubernetes. Then what about OpenShift? So I'm just comparing with Kubernetes and OpenShift. So this is Kubernetes. In addition to this architecture, Red Hat adds some more features which will be very much useful for DevOps engineers or the production environment or our enterprise environment. So in addition to this Kubernetes, this is Kubernetes environment. In addition to that, DevOps tools, containerized services, runtimes, platform services, additional extensions. So Kubernetes is a subset of Red Hat OpenShift container platform. So Red Hat OpenShift is a platform as a service. In that platform as a service, the container management, the container lifecycle management is managed by CRI-O, just like Docker or any other container, because there are different container runtimes are available. So this is more suitable in OpenShift. That's why they run CRI-O in OpenShift. And the operating system is Core OS, not just normal Linux. It's a Core OS specifically designed for this OpenShift. And container orchestration, that is Kubernetes. And in addition to that, features added by Red Hat. So all together, we call it as an OpenShift. So in OpenShift, we use Kubernetes. So Kubernetes is actually a subset of OpenShift. So far we discussed what is containerization, right? So, and before that, we discussed about the history of application deployment. So we already saw the advantages of containerization, now container orchestration, and also we saw the difficulty in managing containers without container orchestration. Now we move on to the demonstration of OpenShift, which is actually a platform as a service. Using OpenShift, we can easily manage our application workloads by using command line or GUI. So first I will demonstrate with the GUI. So this is something called source to image. We know that source code, which is developed by developers. So developers will create the source code and they keep it in a GitHub or any other source code centralized storage version. So developers will upload or push that source code into the GitHub, and using that GitHub URL, we can deploy our applications in our cluster. I mean, in our OpenShift cluster. So what I'm trying to say is, by just getting the URL or link to the GitHub source code, OpenShift can compile and create image, and using that image, deploy our applications with high availability and scalability. So all these processes we can automate. So that is what I'm going to demonstrate. We don't have to worry about manually entering all these things. We just input the link of GitHub where exactly the source code stored, then a rest of the parameters like the name for the applications, and it automatically, sometimes it automatically detects what kind of source code is. If it is PHP or Python or Node.js, based on the source code, it automatically detects the source code and also adds the base image, because we know that for creating that images, we need a source code plus the base image. So using that, we create images. So this is something called the source to image. This is in detail, like developer keep their source code in Git. Then we automate this process, source to image, building the image process using S2I process, and finally using that container image. So the container image is the outcome of building the source code. So using that container image, our application will be deployed with multiple replica for high availability, for load balancing. So this is what we're going to see. The demonstration of deploying our applications in OpenShift, Red Hat OpenShift container platform. This is the dashboard. I'm just checking chat box. Yeah, I think doubts and questions we can have a separate session at the last after demonstration. Yeah. And for accessing this lab environment, as Szen told earlier, you will be getting LMS access. So in LMS, all this information will be available, and also this recorded video. So don't worry about practicing in your lab environment. I mean, what I'm going to demonstrate in this OpenShift is absolutely free. I mean, you also get this free access to these labs. So the lab link will be available through the LMS. So later on, when you get access to this recorded video, you can watch and practice in your free lab section. Yeah. So this is the dashboard of OpenShift, Red Hat OpenShift. So we are going to see how easily we can deploy our applications. So for demonstration, I can show you different demonstration of Red Hat OpenShift application deployment. So we'll start with a simple source code in my GitHub. So this is my GitHub. There I have a PHP in S2I branch. And that's going to say, welcome to OpenShift. This is what it's going to serve. I mean, this application, it's a simple one. But our objective is not the source code or the designing of application. Not that. Our objective is to understand how easily we can deploy our application in OpenShift with high availability and scalability. That is our main objective. So this is our URL. Okay, so I have the URL to the GitHub repository. So here there is an option. There are different options like getting started with the samples, then container images. If you have the container image, you can start with that, or you can go with the developer catalog, some templates, then pipelines from local machine. So currently we have the Git URL. So I'm just click on import from Git. Yeah, this is my URL, github.com, Szen John. Yeah. See, the builder image is detected automatically. It's automatically detected that this is a PHP. Sorry, I didn't mention that branch. Branch is S2I, and context directory. Where is that PHP file? As per this information, context directory is PHP hello world, and this is index.php. So branch S2I, then context directory PHP hello world. See, it's automatically detected PHP 8.0. That's it. Application name, yeah, you can customize with your own names. And resource type, yeah, this is important to understand. By default, it shows in this lab, by default it shows serverless deployment, which means by default there won't be any containers. By default, the container number is 0. Whenever if there is any request comes to that application, it automatically creates a container, because container is lightweight, right? So it takes only seconds to create a new container. So either you can choose serverless deployment, that is by default no containers. Whenever there is any traffic, it automatically creates, and based on the traffic, it automatically increases the number. Or we can go with the deployment, which means at least one container runs always. So we will try both scenarios. So now deployment, and create a root. So create a root means a public URL so that you can access my application over the internet. So that's why create a root. So exposes your component at a public URL. So I'm just creating this application. So what is happening now? It actually creates an image using the source code. So if you go to that build section, so here it is, build is running. So building what? Building the container image. Using the source code and base image, OpenShift builds the image, and using that image, OpenShift deploys our application. And first, we are going to see the feature called self-healing. Self-healing in the sense, when I delete that container, it automatically creates a new one. But in last demonstration, when I deleted the container, yeah, it completely stopped and we had to create a new one. So now the push successful. Let's go back to, yeah, now build complete. This is the URL which is available over the internet. Yeah, so how we can test self-healing? Here we can test. So one container or pod is running here. It's running here. So I'm going to delete. So please watch carefully. When I delete this pod, pod is nothing but inside the pod we run the container. So for the time being, you can consider pod and container. Container runs inside the pod. So when I delete the pod, it actually deletes the container as well. Yeah, you can see that multiple pods are running now in a load balanced way, not a single container. It automatically creates multiple containers just to manage the traffic. But if I delete one manually, it automatically creates a new one. See, yeah, it happens in a second. It is not nothing going to happen with the deletion of any port. Terminating and another one is creating. You can also try in your environment. I'm just pasting this URL in the chat box. And just pasting the URL in the chat box. Please try from your end and try to crash this container. Okay, take it as a challenge. You may think that this is a simple text, but think about how many traffic's coming to the container, right? So think about that. I know it's a very simple text, but our objective is to understand how OpenShift manages the traffic with load balancing and auto scaling. Still, the page is accessible, right? Just checking. Yes. See, you can auto scale port because minimum 5 ports is required to manage the current traffic. Here you can observe the traffic, how much CPU, memory. So just compare with the previous demonstration. In previous demonstration, I just created a container manually without any high availability or scalability. But how? But now we managed to deploy an application with high availability and scalability, and also you can monitor. So with this, we can guarantee high availability, no single point of downtime because multiple containers are running here. Unlike instances or a cloud instances or virtual machines, containers can create within seconds. Seconds is enough to create new containers. See, I'm deleting a new one. Terminating, but automatically creates a new one if it is required. Nothing going to happen. Terminating, still the page is accessible. Here, edit horizontal pod autoscaler. So what happened actually? Here it mentioned, yeah, it automatically configured minimum 1 port, maximum 5 port. And when the CPU utilization reaches 10%, create a new port. Yeah, purposefully we decrease to 10% so that you can see how the auto scaling works. And memory utilization also 10%. If it is goes beyond 10%, it creates new containers. Still, 5 containers are enough to manage our workload. No downtime, right? Still, the page is visible, right? Okay, there is questions like, can we assign dedicated IP address for the applications? Absolutely. Actually, we don't need to assign. We don't need to worry about manually assigning dedicated IP address. It automatically does with the root. So in a real production environment, we use the DNS URL, right? I mean, when we access the application, we use the application DNS URL. Yeah, if you want, we can do that dedicated IP address. That is some more advanced because you need to understand the architecture of how the pod container communicates with the load balancer, which is nothing but service in Kubernetes and OpenShift. So service is in a private network. So we can expose the private network with the public IP address. So the answer to your question is yes, but normally we don't have to. We have some other mechanism to like root in OpenShift or Ingress in Kubernetes to manage our external traffic. Yeah, this is accessible to everyone, right? Let's see some other way of creating containers. For example, this is using Git URL, right? So suppose if we have the container images, I mean, this is also from, builder images here. So we have Node.js, basic Python. Yes, just click on basic Python. This automatically takes the URL of the Python, then create just for testing. I'm creating another Python application. See how easily we can deploy our application. So build is running. The first application is still running without any downtime. So you can do this workshop later, and these links and everything will be provided in the LMS. So different kind of application deployment in OpenShift will be provided in these guidelines. So how to access this lab and environment, everything will be reported here. Yeah, Python is still running, right? And just I'm showing some other applications, right? Any kind of applications you can deploy based on the availability of source code or images. So that is also ready. The thing to understand is how easily we can deploy our application. That's the main thing to understand. So Python application is ready. So this is the URL route to, it's getting ready. Just give me some time. Yeah, now it says just hello world. It's a Python application. So the content of this application, it depends on the source code that is taken care of by the developers. So two applications are running now. Okay. Yeah, this is the lab environment you are going to get with the LMS, that is OpenShift and the developer sandbox. So yeah, you will get access to this page. So when you get access to this page, you can click on developer sandbox for Red Hat OpenShift. So this is three areas. This is three areas. How we can say this is three areas? One is development. So if you are a developer and you want a development platform, just launch this. So I repeat, if you are a developer and if you want to do some development on any kind of programming language, So you are going to get a development platform as a service. So when you log into that development platform, there you will get choices of different programming development platforms, whether it's Node.js or Python or .NET, Ansible, Bash, Apache, Go, Java. Yeah, all these platforms are available. So what is the advantage of creating workspace in OpenShift? There is no dependencies to your system. So you can access this platform anywhere in this network. So basically, when you create a platform in OpenShift dev spaces, for example, I'm going to create an Ansible platform. Okay, so I'm creating an Ansible platform and just look into our topology. Currently, we have two applications here. I mean, two sets of applications here. See, new workspace is running. So when I created an Ansible workspace in OpenShift dev space, it is actually a pool of containers or a pool of pods. So for a developer, it's just a platform as a service. But for an OpenShift administrator, it's a single pod or a pool of pods. So currently, it is only a single pod or a single container. I can say single container. So this workspace is served by an OpenShift container now. So in developer end, I mean, this is an Ansible, so they can work on here. So new file or playbooks, they can write here. Some playbooks are available here. So as a developer, they can work remotely without any dependency on their resources. So please try to understand, for a developer, they don't need to worry about the resource allocation, CPU, memory, resource. For developers, this is enough, right? CPU, memory, and storage. So it automatically manages by OpenShift. And who manages that? OpenShift administrators or engineers. So the thing you need to understand that everything is in OpenShift, everything is a pod or a container here, or a pool of pods or pool of containers here. So for a developer, this is a workspace. What about another one? So now we are in the era of AI, right? So developers develop their applications through these Red Hat dev spaces. And the advantages is they don't need to bother about the resource allocation. And what about data scientists who creates AI ML models? So I'm going to launch that OpenShift AI here. And for creating these models, in addition to this CPU, memory, storage, GPU also require, right? GPU. So this is the platform for AI, I mean data scientists, for AI ML workload deployments. When they create any workload in AI ML workspace, again, this is going to be a pod or a pool of pod of containers in OpenShift. So just for example, I'm not going in deeper with AI because that is not our topic. Our topic is how OpenShift, because AI model and all, it's part of data scientists. But here we are focusing more on OpenShift administration and engineering. And I'm trying to demonstrate when we create some workload in AI, OpenShift AI. So it's a Habana AI is a server for creating and deploying AI models. PVC means persistent volume claim. It's a storage. It's everything automated. It's creating. It's actually provisioning the environment for AI ML platform. And let's check whether a new pod or a pool of pod is going to create here. Currently we have 3, right? One is Python basics, we just created earlier. So what we do, we just delete this just to avoid any confusion. Yeah, when you delete, oops, sorry. Yeah, I'm deleting that PHP application which I created earlier. And this is Python that is also I'm deleting, sample app. And this is workspace for Ansible. I'm just refreshing the page. Yeah, and deleted Python basics as well. So this is workspace for Ansible. Now let's do AI platform here. Okay. Just to show you that when a data scientist create a workload uh, in OpenShift AI, which is actually going to be a pod or container in OpenShift. Yeah. Just running a model server. Add a model server, just a test. I'm not sure about this is a free lab, so just checking support GPUs. But just I want to show you that workload is yes. So when I created that AI workload in OpenShift AI, it is actually a workload here, a pod. Scaling to 0, yeah, it's creating, but anyway, it's already initiated. Workspace is running with the one pod. And whenever if there is a huge traffic or not only traffic, network traffic, whenever if there is any uh, requirement of more CPU and memory, it automatically scale out or scale up. Yeah, that we have to manage as a cluster administrator or OpenShift administrator. Yeah, that we are going to discuss next. What is the responsibilities of OpenShift administrators or platform administrators? I'm just closing this alt tabs. Yeah, it's just taking some time. Okay. So this is actually a workflow for data scientists. So that is not with our topic here. So that data scientists will take care of that. So they will gather the data and create a model and deploy. So the point is, when they deploy any model, it is actually going to be a pod here. So when we come back to the slide, Okay, what is Red Hat OpenShift AI? Yeah, we just saw that the option is available with OpenShift. So which is actually a product integrated with OpenShift. So OpenShift AI is for data scientists for training, developing, and deploying their applications. So in later on, I expect different models will be available as a template, like images for containers. Different model images will be available from Red Hat or from Git repository, so we can deploy and make take advantages of that. But this is the concept. OpenShift AI is technically I can say it's an operator. Again, then we need to look into what is operator and all. But simply, it's a product we can install in Red Hat OpenShift. So OpenShift is actually a platform as a service. Platform as a service. So it can be a platform for developer for developing their application, or it can be a platform for data scientists for developing their ML workloads. But for OpenShift engineers, this is going to be containers, like I showed earlier. This in backend, this is going to be a container or a pool of containers. So this is the model. So data scientists create, test, and deploy the model, and developers, they create their application to serve the work model, I mean AI work model, to the customer or the client. So the customer or clients actually interact with the front-end application, and the front-end application serves this working model. So this area is managed by data scientists, and this is managed by developers. So now the question is, then who manages the cluster in which all these AI, ML, and application workloads runs? So who plans, implements, and manages OpenShift clusters in the enterprise? So primarily it's responsibility of platform engineers, system administrators, cloud administrators, and other infrastructure related IT roles who are responsible for implementing and managing infrastructure of applications, or like enterprise architects, SRE, DevOps engineers, they design the infrastructure for applications. So data scientists taking care of AI/ML model creation and deployment, developers taking care of the front-end applications, and these engineers or administrators will take care of the cluster in which all these workloads runs, whether it is AI, ML, or a normal application-related workloads. So how to gain these skills? I mean, OpenShift skills, because I know that from the beginning, when I checked with the audience, I came to know that some of are not familiar with this technology, so they may be interested in how we can start gaining these skills. So before we start with gaining OpenShift skills, I would recommend Linux proficiency. You mean for demonstration and simple understanding, I demonstrated in GUI, but in a real production environment, we use automation, right? Automation scripts and all. So we need to have an idea about the foundation of operating system, basic commands, then containerization concepts like Docker, container management basics like Docker, Podman, or Cryo, or any kind of container engine, so that you should have the idea about how the containerization and container creation works. Then container orchestration basics like Kubernetes. Familiarize the architecture and core components of Kubernetes. Then networking knowledge, because of course all these things are connected in a network. So IP addressing, DNS, routing, etc. In Kubernetes and OpenShift, we use declarative syntax. Declarative syntax or format in the sense we just declare like, okay, I want an application in this way. Like I want a web server with a true replica using this image, and which uses the minimum of 10 micro CPU and maximum of 1 CPU, or minimum of 100 MB and maximum of 1 GB. So that kind of declaration we can declare it in a JSON or YAML syntax. So understanding YAML's JSON syntax for defining resources. Then version controls like Git. Yeah, you should have an idea about how the Git works, like I demonstrated earlier. So using the Git URL, right, we just demonstrated deployment of applications. Before deploying application, it automatically created the images. Then scripting and automations, Bash scripting, then yeah, Python, basic Python skills, then automation tasks, like for example Ansible. So using Ansible, you can manage the deployment of application in OpenShift. Then cloud computing concepts, it's optional. So in cloud, right, delivery of compute, storage, network as a utility, and cloud, we have different services like platforms as a service, infrastructure as a service, software as a service. And OpenShift is one of the service, like that is platform as a service. So concept about cloud, then administration knowledge of Red Hat OpenShift, Red Hat OpenShift administration. So this is what I recommend for those who wants to gain skills on OpenShift. Okay, so now I'm going to take the questions in the chat box one by one. So PowerPoint slides available after this meeting. Yes, that will be shared through LMS. Then can we assign dedicated IP address? Yeah, that I already answered, right? Then while creating a pivot pod in two node cluster, container D get created by choosing both node, right? Yeah, Munir, that is taken care by the container orchestration. So there will be a scheduler to schedule the pod. So it depends on some rules like affinity, anti-affinity. There are different rules to be followed. So for high availability, the two pod should be deployed in separate nodes, right? So that is taken care by container orchestration. Can we host SQL database in container pod where the database stores in that? Yes, we can host SQL database in container pod, but the thing is, it's not easy like front-end applications like Apache or any kind of front ends, because this is database. So we cannot create replica set for database, right? So we create stateful set for that. So again, that is more advanced topic in OpenShift and Kubernetes, but answer is yes, we can. We can do with the help of stateful sets, but that is not easy, which is very much complicated, but we can easily manage with operators. That is another concept in Kubernetes and OpenShift. Is it similar to Docker images from Docker Hum? I guess it's related to some models related to AI. Anyway, for container, we need images to create container. For deploying AI/ML models, yes, again, the model is required to deploy in OpenShift cluster. If Kubernetes, Docker, Jenkins can take care of, why we need to choose OpenShift? What is OpenShift providing extra features? If Kubernetes, yeah, that's what I demonstrated Munir earlier, right? In addition to that, this kind of dashboard, then S2I that stores to image, then more on that, the support from Red Hat, because not only OpenShift, there are other products like Red Hat Enterprise Linux, Red Hat Ansible automation, or any other products like Red Hat IDM, Red Hat storage like Red Hat Ceph. So in addition to this software technologies, Red Hat provides support. So that the support is the main challenge of open source technology, right? How we'll get the support. So with Red Hat OpenShift, yes, as a Red Hat OpenShift administrator or engineer, you will get support from Red Hat as well. Is AWS free of charge to use? Yeah, that's for the 1 year. You can run the instances. I mean, I think 750 hours per month you can use. So you can try AWS free Terracodes. PowerPoint we can share through LMS. Rahul, in regards to the storage, yeah, we store our data in a storage cluster so that there won't be any dependency in the pod storage or any kind of host level storage. Okay, what are the use cases of container where we use containers? Use cases of container like like I told earlier, it's lightweight, right? So for serving a web server, web pages. So in AWS to serve a web page, you need a 1 CPU, 1 GB minimum, right, for run an operating system in an instance. But in containerization, containers are lightweight, and it takes only very less time. I mean, it takes only seconds to create the containers. So when you get a chance to deploy an application with the load balancing and auto scaling, within a short time, we can manage our applications. So use cases are many, but containers are not suitable for running as a hypervisor. All right. Apart from this, some exceptions like if there is more hardware dependencies required, like acting as a hypervisor, which is not possible. Otherwise, because we are in the era of applications, right? So all these applications, we can make it as a containerized image, and using that container images, we can deploy our applications. Jenkins features available inside OpenShift console. Yes, Munir. Yeah, we can integrate OpenShift with Jenkins for advanced level of CI/CD pipelines. Yeah. So today's session is just an introduction to OpenShift. So cluster management and engineering. Yeah, it's a huge topic to discuss. Is there any backup kind of integration available as a part of on-premise OpenShift? Backup kind of integration available in the sense, I didn't get your question. Pod container creation in production, usually, you do with Ansible, or we can follow GitOps concept, right? Like I told you earlier, YAML JSON format, we can keep it in Git, and we can apply using. So in OpenShift, we have the commands like OC apply, OC create commands. So we can, just like a creation of software, we can deploy the infrastructure using this resource manifest. Yeah, with Ansible also we can. It's one of the method. Is AWS free of course? Yeah, free of course for 1 year if you use free Terracodes. So Munir is asking how we enroll to this course. Before giving you the course details, Munir, what's your experience? Like, are you familiar with the Linux networking automation and all? So if not, you can start with the Linux, then automation, then OpenShift courses. Again, I can paste the link in the chat box. So DUA 280 is the course for Red Hat OpenShift administration. So this course directly goes to the OpenShift administration. So if you are new to the Linux and automation, then RHCA and RHCE will be helpful for knowing the basics of Linux, containerization, and automation.
Those who are looking for the course can put an inquiry through that the course page.
Okay. And RHCE is for automation using Ansible. DUA 280 is a course for OpenShift administration, and RHCSA for getting idea about Linux administration and container technology. Then RHCE for Ansible automation. Between OpenShift and Kubernetes, which have better security feature? Mark, understand that Kubernetes is a subset of OpenShift. So more security we can apply with OpenShift, because Kubernetes, whatever features are available in Kubernetes, which will automatically available in OpenShift also. So in that way, more features we can expect in OpenShift, because Kubernetes is a subset of OpenShift. Because Kubernetes is the container orchestration engine for OpenShift. So more features. When we will receive this role, yeah, that will be delivered to the LMS access. More about how Kubernetes works in deployment process. Okay. Again, that's a huge topic. Yeah. So if you ask me more about that, yeah, just go through that LMS documentations. I mean, for the practical sections. By going through that, you will get to know more about how the deployment process works. Otherwise, the same like what we had done in our demonstration, we just used a container image or a Git URL to create a application with some replica and auto scaling and all. Then HPC with containers can possible to improve scientific applications. Yes, yes. Either we can scale up or scale out. Depends on requirement. So either you can increase the resources of a single container, or for better availability, we can increase the number of replicas. Of course, scientific application, because now we already seen that OpenShift AI. So AI ML workloads takes more resources, right? So that OpenShift can manage. Is OpenShift preferred or Kubernetes? OpenShift is preferred because, like I told earlier, support from Red Hat and more features from Red Hat. And for enterprise customers, the features are more with OpenShift, in addition to the features available in Kubernetes. So of course, more features in OpenShift because Kubernetes is a subset of OpenShift. So whatever features are available in Kubernetes, that is also available in OpenShift. In addition to that, more features and support from Red Hat. That's the advantage of OpenShift. Same like Red Hat Enterprise Linux. When we compare with the normal Linux, more features and support from Red Hat. And for Ansible and for Ceph storage, yeah, everything works like that way. Okay, thank you, Abhijit, for the 10 words. Does OpenShift require additional tools or plugins for more advanced networking? In OpenShift or Kubernetes, we use the concept called operators. So using operators, we can add more plugins. For example, operator hub. So based on your requirement, you can search for the operators from here, then install it. Just like I told earlier, for deploying databases with high availability, we need a stateful set, not replica set. So if you do it manually, it's not easy, but with operators. See, OpenShift AI also a plugin for the OpenShift. So if you go to the administrator page, there is something called operators, install operators. The install operators, it's a plugin. Just for understanding, I'm saying it can consider as a plugin. So here, see, Red Hat OpenShift AI is an additional product or a plugin installed in Red Hat OpenShift. So this way, and developer workspace, it's an operator. So this way, additional features are provided by Red Hat as operators or these products. So the answer is yes. Yes, OpenShift provide plugins which will help you to do more advanced networking. Yeah, the support related Red Hat, yeah, that is commercial, which is comes under sales department of Red Hat. So what you can do is you can try OpenShift. So it's a site here, try.openshift. Try OpenShift. Which means with this you can create a cluster and deploy applications. So after trial period, you will get these details. I'm just pasting that link as well. So this is for the commercial purpose. Try Red Hat. Otherwise, just for practice and all, the LMS free lab is enough. But for your on-premises deployment or cloud deployment, like OpenShift can be deployed in a cloud like AWS or Azure, or it can deploy in on-premises. So that's an advantage of OpenShift compared to maybe in AWS provides EKS, Azure also provides Kubernetes cluster, but that is public. Geographically, it's not under your control, right? So if you want to deploy a platform as a service in your own premises, yeah, with OpenShift and Kubernetes, you can do that. Normal web application with front end and database can be deployed in container. Yes, Blessing. Yeah, there's something called microservices. So front end and back end we can deploy, and also we can implement microservices in which one application is divided into multiple services. So each service is acting as a load balancer with a pool of ports. So for example, in an application, if one search button is actually a service, and another checkout is another service, and each service is uh, configured with the load balancer and also pool of ports. So that is something called microservices. I think I have answered all the questions, right? Any questions pending?
No, sir, you can proceed.
Okay. Yeah, Nitya is asking feedback link. Sijin, if there is any feedback link for
Yeah,
that?
feedback will be there in the LMS. So there is no
Okay.
access to LMS will be, you will get the credentials by mail by tomorrow. And all these things of the recorded video, feedback link, MCQs, everything will be there in the LMS. Okay, so you will get those details by tomorrow. Right?
Yeah. So through
Yeah, you
LMS,
can proceed.
sorry. Yeah. So through LMS, you can view this recorded video and try to do this workshop exercises like yeah. So what you need to know before doing this workshop, like you need to know what is containerization and in orchestration OpenShift that we already discussed, and how to access the developer sandbox for Red Hat OpenShift. For me, it directly got access, but for you, maybe when you click on this developer sandbox, you will be asked to sign up for a Red Hat account. It's just a normal procedure to sign up, and after that you'll get a 1 month free access to this lab. So during this 1 month you can practice Red Hat OpenShift related activities, or Red Hat Dev Spaces or Red Hat OpenShift AI. But mainly we discuss more on Red Hat OpenShift because we are actually platform engineers or SRE DevOps engineers. But those who are data scientists, that is Red OpenShift AI, and for developers, Red Hat Dev Spaces. And you can follow these instructions. I think it's very straightforward instructions like overview of web console, the same thing which I demonstrated with pictures, how to access the web console, just for your information reference. Then install an application from source code. That's what I did, one of the demonstration. Sorry. So log into the dashboard, then use the URL, then launch the application. This is just a OpenShift block which is developed on Python. So this way you can do all these tasks. So it's very interactive. Yeah, all the instructions are provided in this lab documentation. So this link is available through LMS. Okay. What about database services in different Docker or same OpenShift DBMS service? In different Docker or same? Anish, I didn't get your question. See, the architecture is everything is running in a cluster, right? Yeah, there will be multi-cluster with OpenShift. But what is your question? Like whether it is possible or not? Like database services in Docker. Yeah, it's possible. Like I told earlier, for high availability of databases, we use stateful set. Yeah, it's possible, possible. Because most of the things we manage with operators, which makes our life easy. So once you are into the OpenShift technology, or either by practicing these labs or and then doing some courses, you'll get to know more about the architecture and the features of OpenShift. Yeah, then one by one. So after 280, there are 380, 480 different course versions available from Red Hat. So each course version teaches you how to manage different scenarios and different features of OpenShift. So first, DO 280 gives you an idea about the day-to-day administration of OpenShift cluster. Then after that, integration with some other technologies. Then how we manage multi-cluster. Then cluster management, cluster scaling. So more advanced topics will be covered in the higher versions of certification courses. Yeah, that is Anish. With the help of operators, we can deploy the database services. So like in operator hub. So depends on your database requirement, you can manage here. Go into operator hub.io. All these operators you can install in your OpenShift cluster, like how we already installed this OpenShift AI, then Red Hat OpenShift Dev Spaces. These are our operators, and these operators we can customize. Same way, the ready-made operators are available from Operator Hub or Red Hat uh, uh, repository, so that we can download and customize. Yeah, that is a smart idea, Anish, using operators. Yeah. So just look into this page. Maybe you'll get the solution from here, Operator Hub. So I can say for images, you can search Docker images. I mean Docker Hub. For deploying containers, you need image. So the images you can get it from Docker Hub. And for additional features in OpenShift or Kubernetes, you can search here Operator Hub. Operator Hub. Then for installation, some other things called Helm chart. Yeah, there is more things to discuss. Yeah, but this is the beginning of learning OpenShift and container orchestration or platform as a service. So basics things do you need to know for learning OpenShift. Voice is not audible. Am I audible?
Your Szen, it
Okay,
is
okay.
audible.
Thank you. So that's it from my side. Just going through the questions. I think I answered all your questions. Anything else to add, Sijin?
No, they just need to know that all the participants will receive the access to LMS, and also the you will have the procedure to download the certificate from the LMS. Okay, so this LMS credentials will be shared to you by email by tomorrow, and your certificate will be ready to download by Saturday. Please keep this in mind.
Okay, Sherin is asking what after OpenShift? You mean by learning OpenShift, right? Yeah. So you are actually becomes a platform engineer or a DevOps engineer or an architect to manage the cluster, because all this workload is going to deploy in this cluster, and you are the engineer or administrator or architect to manage that cluster. In OpenShift, shall we get a free account for practice? Yeah, through LMS, you are getting access to the free lab. And after that, yeah, you can try OpenShift for a production-based cluster. So for practice, please access the LMS. Through LMS, you will get these links. I mean, access to the free labs. Is there any certificate? Yes, Benita, in the LMS. Once you complete that task in the LMS, you will get the certificate. LMS link, yeah, you will get email. Yeah. Am I right? Yeah.
Tomorrow they will get the details for the LMS.
Okay.
The recorded session will be there in the LMS. You can access the LMS to get the session.
Yeah, thank you everyone for the kind words. Yeah, I'm getting that message in between. Will be there guidelines for completion of labs? Yes, Ujjwal, same like this way. Yeah, these guidelines will be available in the LMS, like this way. Create the application, then use this URL with picture. So what you are seeing in the screen, the same kind of instructions will be available through LMS. Is dev space offered by the Red Hat space? Yes. Because all these images, whether it is a dev space or any images which is actually secured by Red Hat, you can trust that.
All right, Szen, I think then we will wind up.
Yeah.
All right, okay. All right, everybody, thank you for attending this session. Please make sure that you refer the LMS for the videos and to download the certificate as well. And you will get the details for the LMS by email tomorrow. All right, everybody, thank you for your time. Thank you for attending this session. We will see you again for another workshop like this. Thank you all. Thank you for your time. Have a pleasant evening.
Yeah, thank you everyone.